So today we're talking about the second part of the moon. Make sure you have the right note guide in front of you. And here we go. So this is going with the movements of the moon. So the moon orbits or revolves around the Earth every 27 and one third days. So almost every month, not quite once a month. It rises in the east and sets in the west. At least that's what it appears to do as we are here on the planet. It rises and sets just a few minutes later each day, 50 minutes later each day. The moon rotates, meaning rotates on its axis, every 27 days. So notice that it is only one third of a day difference between its rotation and its revolution. So, because of that, the moon, the same side of the moon, always faces Earth. And this is called the near side of the moon. So, as we are looking at this revolving moon here, rotating moon, we will see this darker side, is the far side of the moon. We do not see that side of the moon unless we are in a spaceship or a probe that is going around the moon. So, the far side of the moon always faces away from the Earth, that side, because the speed of the rotation is matching the speed of its orbit or revolution. Now, the dark side of the moon would be the side not receiving sunlight, is not the same thing as the far side because sometimes the sun is hitting the far side of the moon. So don't confuse the fact that it is darker as being the dark side. So far side means away from Earth, near side means near Earth. Should be an easy vocab term to remember. The far side of the moon was first seen by the Luna Russia space probe in 1959. So notice it was not an American probe that saw it first. So why does it look different? We saw that it did look different in the rotating, as we saw it doing its rotation. It has more craters. It is facing the asteroid belt, so it is more likely to get hit by the asteroids. There's very few of the Mera left because those are the blank spaces, the spaces that were just the flat areas left by the volcanoes. And the crust is thicker there, and they think that has to do with the fact of how the Earth's gravity would have affected the formation of the moon. But that's not gonna be a test question. Okay. From Earth, we see different amounts of the moon sunlit up at different times. And it has to do with that very first slide where we saw how there's a tilt to the orbit and the amount of sunlight that hits the moon at any one time lights up a different amount of the moon's surface as it is orbiting our planet. The moon is orbiting the planet. So these are called phases. Full moon, new moon, these things. Waxing and waning. So, at different times, if the moon is directly in front of the sun, it is a new moon. We don't see the moon at all because there's no light reflecting off of it. We will draw this picture and talk more about it in class because it is kind of hard to fully grasp. But notice at all times, half of the moon is in sunlight and half of the moon is dark. So at this part, this is the far side of the moon that is lit up, and the near side of the moon is in shadow. Over here, the near side of the moon is lit up, and the far side of the moon is in shadow. So in this case, this is where we see the full moon. And then when we are at what they call the quarter moon, which looks more like a half moon to us, we have half of it in shadow we see half of the moon in shadow. This is what we see, half of the moon in shadow and half of the moon in the sunlight. But in reality, it is always half in sunlight and half in shadow. Like I said, it takes a little bit of our mind to grasp. So we'll talk about more direct instruction in class. This is just the same picture, drawn just a little bit differently. Maybe it looks a little bit more clear in this picture. I don't know which picture actually makes more sense. The four main shapes: the full moon, the crescent moon, the gibbous moon, and the quarter moon. So when we say waxing, the moon is appearing to grow larger. I think back to Karate Kid. I don't know if you've seen any of those. Wax on, you're going like this, and it's getting bigger as you wax on. That's how I remember waxing means growing larger. Waning to me sounds like whining, and whining are little kids. And so to me, that means something small. I know it's silly, but silly things are what helps me remember. So if it helps you, great. Gibbous is larger than the quarter, but not as big as the full. So somewhere in between a quarter and a full moon. And a crescent moon is less than the quarter, but I can still see it. Like a banana. Crescents look like crescent rolls, bananas, whatever makes it easier for you to remember. Okay. And remember that phases are just a change in perspective. So the moon isn't changing sizes, it's just how things look according to how the moon looks according to where it is in its orbit around our planet. And so here we're looking at how the orbit of the moon is slightly off our plane. Lunar eclipses. This is when the moon moves into the shadow of Earth and the shadow covers up the moon. This happens relatively quickly. It happens about 2 to 3 times a year. Takes about 4 hours. So we can watch this happen, sometimes in the morning, sometimes in the evenings. It depends on which eclipse we're talking about. And notice when this happens, it looks like it's being kind of like cut off. It's not as circular. This is not a crescent, right? It looks different. I know some of it's not, you have to really know your shapes of the moon to realize that that's not the shape that it normally is. Solar eclipses, totally different. The moon is moving between the Earth and the sun. So that means the moon is casting a shadow on part of the planet, Earth. This is really rare, and it only happens once every 360 years on any given location. So it does happen every so many years, every 2 to 4 years, we'll see a total eclipse, but in a given location is really, really rare. Anyone remember what this is? What part of the sun this is? This is the sun's corona. Did you get it right? The next solar eclipse is coming very soon to our area, 2024, in April. So you guys will definitely be around for that. Even here, I mean, technically we won't be in the complete eclipse, but it will be close enough. So we don't have to travel to Indianapolis. Even from here, it will look like a total eclipse. So very cool. Remember, you can burn your eyes out if you don't remember the last eclipse. That is why you can't look directly into the sun. But it's even more so during the eclipse because you don't realize it. Most of the time, you look at the sun and it hurts your eyes, you look away. During the solar eclipse, you're not getting quite as much direct sunlight, and your eye doesn't realize that it's dangerous. You look at it and it will still burn your eye permanently. And we are at the end of our lecture. I will talk to you soon.